Prof. Good morning, sir. Chemistry. Good morning from Togo, Ghana, thanks for everything. We appreciate it.
Internet of Things, some people call it intelligence of things. It deals with I don't want to go into the details. The facilitator and the director will take our principal officers around for the commissioning of the equipment. We have here in our midst our DVCs representing the Vice Chancellor, starting with DVC Academics, Professor Mrs. Balola. You are welcome now. Our DVC Administration, Professor Daramola, you are welcome, sir. And DVC Research and Development, Professor Innovation, sorry about that, sir. Professor Atieni, you are welcome, sir. We have other representatives here. We have Director of Works here. You are welcome, sir. Thank you very much. We have Head of Water. Don't know. Oh, okay, you are also welcome, sir. We have professors here.
Yes, sir.
You are also welcome, sir. Thank you, sir. Professor Koya from Mathematics, you are also welcome to our meet. Now to make it brief, I'll now call on the facilitator and the director of Institute of Ecology to step forward and lead our principal officers for the commissioning purposes.
Professor Oniwa, can you introduce member of the
Okay, good morning, the DVCs. It's a pleasure to meet you all once again. I should apologize for not being appropriately dressed, but we've been trying to set things up on the field since morning. Briefly, I will just introduce my colleagues who have also played a role in setting up this. We have Dr. Kingsley Obodo from the Northwest University in South Africa, Dr. or Associate Professor Solomon Gizao from the Addis Ababa University, and I am Clement Onime from the International Center for Theoretical Physics located in Trieste, Italy. We also have representatives of this installation was also alongside a week-long workshop where we took the participants through hands-on sessions on Internet of Things or Intelligence of Things, as we have heard earlier. So we have representatives from Ghana, okay, from Ivory Coast, from Togo. So we are also thankful to our sponsor, Wakren, who try to make sure that they arrive here on time. And I think they covered their transportation from Lagos, at least from Lagos here. We also have representatives from other institutions, neighboring institutions. I believe representative of Bowen. Okay, University of Ibadan. I don't know if they were able to make it out here. Of course, maybe was there Futa? Okay. Also, we also have a big delegation from the Obafemi World University, Ileife. Professors, graduate students, and academicians and researchers in general. I think it's been an exciting week. And we've interacted with people from various fields, from veterinary medicine all the way to chemistry, to physics, to electronics engineering, and computer science. The technology we deployed here is something that is cross-disciplinary and can be used by various academics and researchers for their scientific work. I forgot to mention the contributions of Inteku as well. The director of Inteku. Okay, that's a great idea. So Inteku has been fundamental to ensuring that everything we are doing works smoothly. So without much ado, I believe that's for the introduction. So without much ado, we'd probably like to invite the Deputy Vice Chancellors representing the Vice Chancellor to declare the system open, and then we'll proceed, if you don't mind, we'll proceed to see the box and see the sensors that were deployed and just talk a bit about the science that was there. I think I should mention formally that we also thank the Vice Chancellor for his hospitality, reception, and support since Monday. We've been on this. So thank you very much.
Thank you very much. I think we can move towards. We appreciate the Professor Winime and your team completely, because what we are doing is international. We have almost all regions represented. This is a national, we have people from Nigeria, is a regional from all over Africa, and it's international because we have completely. So it's one of its kind that has not happened there before. But one thing that is of note is that this thing was purchased by the students, by the PhD students of Dr. Mrs. Okoya. Where are they? I think there are two of them.
And Mr. Agbabu.
Okay, yes. So let us clap for them. Yes. The two of them contributed to purchase this. So that
purchase the sensors.
The sensors. So that means the development we are experiencing in OAU is not limited to staff alone. So our students too, they can join us. They can join hands with us to make the university better. And this is also going to enhance our rating. Sincerely speaking, I thank God we have a lot of intake here. So we want our students, other students that are here, to please emulate this kind gesture for these two PhD students so that we can move the university forward. The MC, introduced the Dean of Clinicals, maybe because throughout 1 week that these people had been here, we didn't have cause to rush anybody to the hospital. Yes, Dean of Clinicals, Professor Showaide, thanks for coming. Yes, who has been introduced? I think everybody has been introduced. The Director of Works, please, maintenance, come here because this is me. On behalf of the Vice Chancellor, I want to commission this for humanity and the God of God Almighty. Who is leading us? Professor Ozile?
So we will have to go in batches to respect the guidelines that the Director of Works, the Director of the dam have laid out.
How many people?
Myself and the three directors, the three deputy vice chancellors. Then for a second round, I'll take the various directors who are present.
And professors.
And then professors will come in another batch too. So we want to keep minimal 3 to 5 people on the system at any time.
Don't step on that metal slab.
Yes, we won't, yes.
Metal slab. Cameraman.
Yes, it requires maintenance.
Yes. Okay, the one at the back. So that's what we should not step on.
Yeah, we won't step on that. We'll have to sort of go around. So cameraman, okay, so we can come this way. Have the box containing the sensors. We decided to power it via solar cell, so it's completely independent. It doesn't need electricity. And internally, we've mounted a couple of batteries to try and keep power during the night. So the idea is to have energy, and the system is taking readings day and night. And then we also plan that even on days where there's no sunlight or there's a lot of rain, batteries will still keep the system running. And once the readings are taken, we have a couple of cables taken down to the water to actually read the readings from the water and then bring them back up here into the box where they are processed, and then they are then transmitted via radio, this antenna. Okay, they'll then be transmitted via radio using this small black antenna here to the Interco building, which is somewhere over there on the main campus. And then from there, it's available to researchers. So researchers don't have to come here physically to take their data. And we've tried to build in various redundancies in case there are failures. There won't be loss of data. But we expect it to be a big boost to researchers on campus. And I'm happy to let the DVC academic know that there are already a lot of side research projects that appear to be springing up after the workshop. The workshop participants were quite enterprising, and it will be very useful. Okay.
Thank you very much. Well done.
Yes.
We pray that God will continue to be with you, guide you, and reward you greatly.
Amen.
Thank you very much.
Thank you, sir.
Thank you.
I'm not going to.
You can go through. Let me go through this.
This is the solar.
Yeah, the probe is lost in the water. Probe ni wọ́n jù lọ sílẹ̀. Ó ti lọ sínú ẹ̀bẹ̀. So, but the circuits are here. So, this is the solar panel. We will supply power to it to keep it working. So,
I have a question.
Okay, sir.
Does the water of this spot does it represent total water in all the?
That's a very, very good question actually. From monitoring, from my own knowledge of chemistry, we usually take samples across where we come from. We call it compost analysis. But after whatever is here, they give us whatever that is there. But I got the point.
The water is like solution so anything there.
Because
I don't know the flow. What's the flow direction?
This is the flow.
It flows.
So not
exit
so
at that place.
So whatever it is, if the pH supposed to be like 7 originally, so and that point is like 7.8, is 7.4 here, is 7.6 here, it's still representing something. It can't be the same all over.
The range will be there, plus or minus.
It's still within the range. When there's any problem, there's an option in the pH that now goes to like 9. We know there's a problem.
There's a problem everywhere.
There's a problem everywhere.
Now those who are doing research, they will have to.
Okay, no, I know.
Yes, Pascal is different. I work with all of them, so it's crazy. Okay, so if you remember, yeah. Solomon, you're not supposed to walk on top of this. You can fall in.
Wow. With his weight.
If you fall in, I will simply call the ambassador. I don't know Solomon Kisa. So this was what we assembled yesterday, and we finished finalizing the connections this morning. And we've dropped the cables to take the probe down to the water. But there are some concrete we might need to some bar here. Hitting about 14 volts. Okay, and so it's charging the batteries are fully charged, and then it's driving the load, and everything is operational. Okay, we will lock this with a key. Okay, and we'll lock it with a key as well as this, and that's it for 24 hours operation. I know they offered us to also lock that gate, so nobody can even come.
Yes. I think it's good.
Yes, so that's what we've been able to do for security. We appreciate you guys for coming, and we look forward to doing something similar in your countries as well. Yeah, I understand you, my brother. The point is, right now we are just trying to make sure we can start collecting data this week. Maybe in 2 months' time we might decide that, okay, let's find another location. For example, maybe we can go and site it on that area. Okay, or even if we can go out in the middle. But one problem is this is a reservoir, and I understand it's about 15 meters deep. God! So you will need a very long pole to get to the bottom. Okay. We looked at, I think you were with us when we went to the institute. We tried to get to the water around the institute. So we still feel that eventually we might move it from here. But this is just a start. So we start. Okay. And eventually we'll improve on it. Or even deploy more. So maybe leave this one here, put another one elsewhere, and start comparing readings from various locations. Our plan is to do this one here, then we go and do another one at a river about 50 kilometers away, and another river maybe about 100, 150 kilometers away. So that will be for the southwest region of Nigeria. Hopefully this will grow to be, maybe we could have 100 installations. This can be. Shall we go?
I missed your
Prof, I saw you actually was telling people already about it. So
okay, then it couldn't be like yours at all, but I tried at least. How the fundamentals. I just introduced them to the pro. No, they asked questions, very, very fundamental questions. Actually, the one from the clinical. He was curious about the probe. How would whatever it measured this place represent the whole of that place, you know? So that the pH. I said, well, the stable answer I got is talking about composite sampling, where you take here, you take there, you take there. I told him, yeah, the pH cannot be the same at this point, based on whatever reason or the other. But what is important is if the pH is 7 here, it couldn't be more than 7.4 that side. Or 7.6, 7.2. So it's whatever this one measures is within the range of what happens here. And if there is any upsurge that is going to be hazardous, like it measures 10, I will know there is a problem. And that's the essence of
over
that.
time, even if the pH is 7.5 there and 7.6 here, over time we should expect that the whole pH will level up.
Yeah,
so
yeah,
if you
because
measure for 24 hours continuously,
yes,
the measurement you get here should be
he also asked that question. I say it's continuously, you know, our basis, and the whole measurement is going to the cloud somewhere. That you guys are the interpret here are receiving from time to time, where we can always surface the data. I think to a large extent I'm satisfied that.
No, you did.
So the problem that part is dangerous. Okay, so please don't step on the metal, and please don't go towards the edge. We are safe from these poles, from these 2 poles.
You can come in more. You can go there. You can come in more.
Okay, so I believe you guys were all in the.
You can go this way.
All at the installation yesterday. Remember, I was putting the board and the batteries and everything. The solar panel. You can see the charge controller already reporting that the solar panel is generating 13.3 volts. It's charging the batteries, and the batteries are driving the load. Okay, so it varies. That's the interesting thing with solar energy, it's not constant. So even slight variations in the intensity of the sun will cause the voltage to drift. That's why you have the charge controller. But the charge controller simply makes sure that 12 volts is charging these guys. And our load is 5 volts to power the board. I think, and then the board has the SD card as well as the LoRaWAN connectivity, and the target is, I think, some of those masts there will be Intecus. Okay, so we are hoping to be picking up the signal from there. I think it won't be too far. adjustment to move the cables away from the wall. But officially it's already collecting data and uploading them. Okay, any questions, comments? So we thank everyone for their comments and contributions. As you can see that our pole is no longer the highest object in this vicinity, and I believe the electrician was also here this morning, and he will fix the earthings. So as long as we can assure that the railings are earthed, the whole system should be protected. These are the highest objects here. So those ones will represent an issue, and then those poles are also higher than this. So I think we are much more secure in that regard.
Can we fix the battery without you? Can we actually fix the battery without you being there?
Yes, I mean, to fix the battery is just a question of tracing the cable, these two, and removing these ones and plugging in whatever battery. So
what about if you have any fault on the board?
We have a description of the connectivity. Okay, we have a description of the connectivity shown here.
Then can we likely have these all those chipsets to get, as in to replace them around us here, or maybe until
yes, we can get everything, and the only one is this brown board. But for the brown board, we are going to prefabricate and etch the board, so there will be a template. If you have a lab where they can do electronic boards, you can always remake them. Okay, it will have the holes where you put the various ICs and the connections and stuff like that. So once you have the board pre-made and you put in the right ICs and then you load the program, it should be ready to go. So easy to replicate.
Okay, so the other time you were talking about calibrating the probe.
Yes.
I didn't actually get if we are using the normal the usual calibration, or maybe a computerized calibration.
Okay, so to calibrate the pH sensor, we'll have to bring it up from the water.
Okay.
Wash it with distilled water.
Yes.
Dry it, and then put it in a the standard buffer solution. But before we do that, we will need to move a jumper on the board to tell the microcontroller that we want to go into calibration mode.
It has to be disconnected.
No, the microcontroller is the one that is going to do the calibration.
Okay.
Okay, because at the end of the day, he's going to read. So when he goes into that mode, he knows that the next voltage I'm going to read should be what will be standard, is a neutral pH. Okay, so that for him is the calibration. So once you've done that, you can now move the jumper back to the running position, and you put it back. So you don't have to see any reading or anything, but if you are sure of your solution, okay, then the calibration will be effective. The electrical conductivity has also another process where periodically we have to or is it the dissolved oxygen? Yeah, the dissolved oxygen has a solution that you have to prepare. Okay, and you fill the top of it with that solution. Okay, so periodically that will have to be replaced. Okay, but then that's fine. I don't think you need any advanced calibration outside those. Yeah. So unfortunately, if you want to have sort of like the one you are used to, it means we will have to buy maybe an LCD display, and then we'll have to configure the microcontroller to drive the LCD display, so it will read your sensor and put the value on the display. Okay, and that essentially is what will happen during calibration.
Okay, sir, so sorry. During a pH calibration, you know, there is a particular knob you use to control, to set the actual pH range. Does this one have a knob? A knob as well, or how do we confirm if the pH is well calibrated, even if maybe you actually prepare a wrong solution?
Okay, so essentially you can come with two solutions. Your standard solution and an alkaline or a basic solution. And when you finish your calibration, you can put it, you have to clean it first and then put it in the alkaline solution. And then check whether the reading will be below 7.
Is it going to display on the board here?
There's no display on the board here.
There's no display.
Look at it, there's no display. If you want to have a display, we have to buy a display. That one you are looking at there is just for the solar system. It has nothing to do with, that's not the pH, that's the value of the electricity that
supplied.
This one is supplying. Okay. So if you want to have a display, you have to make a different display. This one just takes care of, we're only interested in understanding whether you have electricity coming to the board.
Is there any possibility we can have instantaneous reading of the data the sensors is collecting?
Yes, as it's collecting them, it's collecting and transmitting every 10 minutes.
To which, what is the source? Where can we access such data?
Okay, right now it's going to go to the gateway, which
mast over there,
which we've placed on the intercool mast.
Okay.
And then from there it's going to a server in Italy.
Directly to Italy?
Yeah, it's going over the internet. Okay. You can also have a copy delivered to a cell phone if you want. So if you are here with your cell phone, you can simply do your stuff, wait 10 minutes and check what the reading is. But it will go there, and then from there it will come to your cell phone.
Okay, it must be processed there before one can access it here.
Yes.
Does that mean anybody can have the data?
No, not everybody can have the data. It's only the authorized people who have access to the data.
Is there any possibility of hacking the server or maybe the gateway?
But dude, what are we hacking? If
This is Nigeria.
No, it's Nigeria. It's Nigeria. That's true. But the question is really the question is very simple.
Okay.
Is this thing going to change my bank account?
Nothing.
If I write from
No. Answer the question.
The wicked ones.
No.
Think of that.
No.
Time you were given lecture, I could
How
hear
is
some people even telling each other like they can easily get this data even without you.
Yeah. I mean, that's not a problem. Okay. But there are two things. What are they going to do with the data?
Just to use it for their own personal
Are they going to? What personal use?
Well, it's not certified.
What has anybody got to do with the pollution in the dam for his own personal use? It doesn't change anybody's bank account.
So besides that,
if you go to a bank and say, I want to sell you data from the Okpa River Dam, measuring chemical pollution, they'll look at you and say, what are you talking about? Okay, what am I going to use it for? Okay, at the worst case, you can do a press conference and say the dam is polluted. But after you do that, okay.
What do we do?
Okay, or you say you want to sell the university a better system for purifying the water. Okay, at that point in time, it's a completely different story. So one, the data is not really like of very high economic value right now. Okay, so it's not something somebody can market. And then point two, if somebody publishes this data, you verify it. Does this data match with what we collected here? Yes, you can call the publisher and tell them that this guy got his data from questionable sources.
It's not satisfied.
And they will withdraw the publication.
Yes.
Okay, and you will put that guy in trouble. He will be in academic trouble. He will be accused of stealing data or falsifying data or publishing without
certification.
It's not. On the other hand, you can also say, okay, if the data is going to be beneficial for research,
yes,
let everybody have it. If you want to move it up and down, left and right, do your own research. If somebody says they want to study whether fishes can stay here, okay, they can come to you, or you can say, okay, we give them access to the data, and they start their own study. Okay, the only thing you will say is acknowledge the institute and the source of the data in your publication. So at the end of the day, even if they end up publishing one paper, it will still be counted as part of the work of the institute. Okay, so in a sense, we shouldn't be too strict. No, well, not too strict, but more about not to stock up on the fact that it's my data or somebody is going to steal my data or something. I mean, if another researcher steals the data and say, okay, he uses it to publish, we can embarrass him, we can call him to order, you can call him before the university disciplinary committee. Okay. And there are all kinds of things you can do to deter such behavior. Or you can even reach an agreement with him and say, okay, you have to write the publishers and publish a rejoinder to your paper. That rejoinder stating explicitly that the source of this data was the Institute of Ecology, blah, 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 blah. Okay. Yeah, otherwise, why hold on to data? You will collect new data. Okay, so even if let's go. Even if somebody okay, so we won't probably take questions, but we'll just take photographs, and then if you have questions, we'll go and deal with them in the class area. I think that's better. So yes, so we assembled all of this in the class yesterday.
I've not listened to any, so let me take advantage of this last.
In fact, we're actually postponing it now to the class. It's just that the previous guy was asking about the security and then asking about data security. So we'll actually deal with all of that in the class. I'll repeat some of the answers when we get to the class. So solar panel is generating 14.3 volts right now. It changes with the intensity of the sun. You get different outputs, but this guy is feeding it to the batteries. Batteries are fully charged and then also driving the board. So the board is already taking data because we've put the probes in the water, and thanks to the LoRa sensor, it's sending the data to the intercool masts, which I think are around that area.
The LoRa sensor is somewhere there, inside this thing.
Yes, the LoRa sensor is on the main board, and this is the LoRa antenna. This black one.
Antenna, the black one.
Yes.
So those are things I'm missing. Okay.
Yes, so we have to put it vertically. I will still come back to make some slight final adjustments, but it's already taking data, and it should be beaming it already if their gateway is up. If not, we'll come back tomorrow and simply take the SD card out, copy the data, and then put it back in. Okay. So are we the last set?
Yes.
Okay, great. So you can witness the locking.
You said we should not ask questions, so when we get to the classroom.
Yes. Okay.
If you have locked it, have your point anybody, I guess.
Yeah, I mean, there are two keys. So there's the triangular key. The point is any electrician has this one.
Okay.
Because it's standard from electricians. But this one is actually a key. And okay. So now it's locked and secured, and nobody's tampering with it, and we only just need to verify the gateway and things like that. Okay, we thank the Edu TV team. Please take your questions and bring it to class.
Building the committee on this day started from the time we were selecting participants for this workshop. We didn't just select on the basis of how handsome you are or how beautiful you are. We selected on the basis of discipline, what your research area looks like, what we can also learn from you. So, and while the workshop was going on, some people were taking notes of the questions that were raised, who raised it, the department, the university. So that is what we will use to gather our team that we work on. We don't just want to have a large team of, oh, I'm there, I'm not available, I will not talk, I will not. We want people that have interest in this kind of thing and whose research areas are also along the line. So we have already prepared our list along that line, and we're going to open. What did you say? What did you send to me? Something on email that we are going to use. There is an ICTP platform.
Okay, yes, we could have our messenger.
We're going to open something like that, and all the participants also will be captured. But we will, if your name is not captured while doing the workshop, and we think your area is on that is still linked to it, we will ask you a deliberate question. Like the prof knows the interview he did before I put his name on the. I interviewed him on phone, isn't it? Yes. Will you be available from Monday to Friday? You understand that kind of question? Exactly. Because I know people are busy, and I don't want jack of all trades, master of none. So we are going to be we want a disciplined group. That when we say we are meeting, they are available and they are relevant to the project. It's just not just, oh, I'm a member of this, I'm a member of that. So we really want to go further than this, because we are writing a proposal already for Nigerian surface waters. And if we are writing a proposal on such a thing, we want people that will add value to it. Because when you say there's a chemical engineer there, there's an electrical engineer there, there's a civil engineer there, and they see the richness of the proposal, it doesn't reflect. Because people are just coming to sign and go. No, we don't want that. We want contributions from people that will be in that. When we have written our own structure, then we pass it around to those people to make their comments. And these are the things that we have in plan. We believe that this project, since it started on the fact that Nigeria has no real-time data for surface water, not only Nigeria, more or less Africa. Because I personally, for 1 month, 8 a.m. to 10 p.m., using ICTP library, that's what I did for 1 month. And they were even sourcing for literature for me in US and everything we couldn't get. That's what led us to this place. So achieving that course alone is important for our country, because if you don't know the population of your people, how can you manage them? How can you provide for them? If we don't know what is in our surface water, how can we propose management strategy? So it's very important we know what is in our surface water. So, and this is just a step in the right direction, which I believe we have all done well so far. And I want to use this opportunity again, because I don't know how much I want to pay the ICTP team. All our resource people came around. Some sponsor themselves, yeah. Some they source for money themselves. Even when they were here, I don't think I'm able to give them what I would have loved to give them. They have tolerated everything despite all the stress, because we just enjoy their goodwill. Even yourself. I don't know how much money you have spent on this thing, and I'm not going to refund any.
It's very easy to transfer. We'll just use the account.
Yeah, apart from money, it's time. I told Professor Onime, I said, this engineer Dewara that you are saying, let us make sure that he does everything before you leave. Because when you leave now, I don't know how easy it will be for me to get him. He's executive. You know, everybody is busy here and there, but like I told our students, that we have enjoyed the goodwill of the whole university on this project. You cannot believe it that for this project we didn't handle cash in this project throughout, and it has gone this far. I mean, it is a great one. So I don't know. I'm talking of I won't refund engineer Adewara. I can't even refund Professor Onime, because he has spent so much that I'm not asking him what is our bill again. So, and we are all heading towards this thing just be successful. So I want to appreciate everyone, even those who spend their time, even my students. I appreciate them. Yes, they are my students, but if you share a vision with your student and you don't catch it, what do you do? I want to appreciate them for catching the vision and for spending their time all the way to get us to this place. The people from all neighboring countries, I didn't have time to even check them where they are lodged. Forgive me, I know I should, but it has not been, the time is just not available. But I normally call and say, I hope you are fine. I'm fine. Okay, so I appreciate everyone. This project is just the beginning. The beginning. It's a selfless service up to this stage. Nobody should think, oh, so person has gained so amount in his or her pockets. No. Nobody has gained any money in their pocket. They have even spent out of the money they should use to eat to contribute to this project.
On a lighter note,
yes, sir.
You still have a large chunk of time for goodwill or good
appreciation. Yes,
yes, because I know some people are taking off. Some people are taking off. And I know
after lunch.
Some people are taking off right away.
Okay,
so
all right.
that's why I'm saying all this. I want to appreciate you.
Okay. Let me just add something to the answer to Engineer Kome. I think we must also acknowledge the contributions of these two students who have been funding the census so far.
Significant.
So I want to say that in the next 90 days, our focus is to ensure that they start getting data that they can start using for their work. Subsequently, we are going to set up a platform and we'll bring people on board, and I would suggest maybe we might have a Zoom call once in 3 months or 4 months, okay, to sort of keep everybody abreast or representative of people who are interested. What's happening, where there are new avenues, and what can be improved. I think I also want to thank all of you for contributing your suggestions. Like I mentioned yesterday, we started out with one idea and we ended up with this. But at least it's working and we are confident that we're going to be getting our data. Okay, so thank you all for the suggestions and various contributions. Okay, so that's follow-up. Thank you.
It was sometimes in June 2023. We tried to research into the quality of surface waters in Nigeria and find a way of using artificial intelligence to propose management. For us to do that, we need certain types of data which we couldn't get sufficient quantity in our search, and for Nigeria, and eventually we have to take it up upon ourselves to collect data on surface waters in Nigeria. For a start, we decided to pick one surface water in Osun State, Oyo State, and Ogun State. And the first one that we are doing happens to be this upper dam at Obafemi Awolowo University. And it was when I visited ICTP that the idea was presented. And eventually the two PhD students that wants to work on those projects, they were able to buy 2 sensors, and the Switch Research Group, which I belong to as the supervisor, also provided 1. And after purchase of the sensors, we needed people to install it for us and collaboration, and that was how ICTP came to the rescue. And from there they took it up, brought in every necessary people, Wakren, through Professor Onime Clement, who happens to be the lead team. And since then, we have been able to install the IoT sensors today. We are very happy that this type, first of its kind, is happening here at Obafemi Awolowo University, Nigeria.
This for us has been an interesting project because it's aimed at improving the quality of data that we have about surface water bodies in not only Nigeria but also West Africa. I should start by saying that I didn't work on this project alone, so I like to acknowledge the contributions of the Science, Technology and Innovation Unit of the ICTP is Professor Emmanuel Petrosemoli, Dr. Marco Zenaro, Dr. Ritis, and Dr. Marco Reinoni. They've all contributed in various ways to ensuring that we had a successful installation today. We've actually tried to place a workshop alongside this activity because we believe in building capacity. So one of the missions of the ICTP is to build local capacity, especially with respect to science and development of science in general. So the workshop had participants from various departments of the OAU, as well as other neighboring institutions, and even some 4 different countries in West Africa. And during the workshop we covered various topics, a bit of the chemistry, a bit of the Internet of Things technology that is driving the project, and also a bit of the renewable energy system that is being used to power the system, as well as the analysis of the data, or how to analyze the data, go about analyzing the data. I think it's been a very successful and eventful workshop hosted by the Institute. So we'd like to thank the Institute and the Vice Chancellor for their kind generosity and availability to host this. Incidentally, my colleagues were here to support me, and I believe that we will not have had a successful workshop without their contributions. So I'll call on Dr. Kingsley Obodo, who will speak about the solar aspects of the workshop.
Thank you very much. I'd like to say that this workshop has been one of a kind. And the reason why I mention is one of a kind is that there was an aspect of hands-on and theory, and then there was device installation. And so the essence of this is that it introduced students not just to the theoretical aspect of what we taught, but also to the practical aspect. But before I go ahead, I would like to thank Professor Onime and his team, Dr. Mrs. Okoya, and the OAU University for inviting me. Now, if you consider Nigeria as a country and where we are located, Nigeria is located close to the equator. The implication is that we have abundant sunlight, we have abundant energy, and are renewable. So taking into cognizance the UN Sustainable Goals, it's upon us that we try to harness this energy in various activities we do. At the current workshop that was organized on IoT and how it's deployed to measure surface water pollution, I would like to commend the organizers for thinking about the renewable aspect. So based on this, I was invited to help with the renewable aspect of the project. So I gave a workshop on renewable energy to introduce the participant to renewable energy, and also on solar panels, which we used and deployed in this workshop. And also of important note is that we talked about solar panel sizing. So I believe that this workshop comes at a very important time, especially to Africa and Nigeria, in the sense that we are able to carry out knowledge that is translatable, that also can lead to spin-off industry. I do believe that at this workshop, what we have covered in the aspect of solar and renewable energy can be applied to actually tackling some challenges that are real to Nigeria and our energy generating capacity in general. So without further ado, I would like to thank the organizers, and I believe that this workshop came at a very timely time.
I am happy to be here and to participate in this workshop and contribute. My contribution was, since as you have seen that this already installed these devices, and I would like I contributed that these participants how they can use this data and then try to use of and analyze it. So in this workshop, what I did was I'm just trying to show them the different kinds of approaches and analytical methods and different kinds of algorithms, how they can use this data to make some kinds of output or result from this collected data. So my contribution was that. So I hope the students already understand exactly the use of this specific data, which they couldn't get it, anywhere. That's really important, and then even to show and contribute in the scientific community about, and then making sure that this water pollution will be for the better use of the community around this area. I hope they can understand, and then I will expect that the students will publish lots of really nice, good papers in well-known international journals. Thank you.